The primary resistor uses a resistor which is placed in series with the motor starter power contacts. These resistors in this start method are called primary because they are connected to the supply side of the motor circuit. The resistors are removed by the bypass start contacts S1 after a time delay, as we'll see shortly. The primary resistor provides at start about 65% of rated voltage and a starting torque of 42% of the normal torque. The current at inrush is limited to 65% of the locked rotor current. This primary resistor start provides a rather smooth motor start compared to the across the line. When the motor is first turned on, full voltage is applied from the power contacts at the starter and voltage is created at the resistors, thus reducing the amount of voltage going to the motor. At the same time the motor is turned on, an on-delay timer is energized. The delay timer contacts drive the accelerating contactor, which controls the resistor bypass contacts. Once the time delay has elapsed, the bypass start contactor S1 will be energized and the motor will have the full voltage at its terminals. As we can see in this graph, the line current kicks back up for a short moment when the resistors are taken out of the circuit and the motor is applied with full voltage. The number of primary resistors could also be increased to provide the motor circuit with more accelerating steps. Each one would be controlled by a separate on-delay timer. The timing relay is generally set at around 3 seconds for a 2-point acceleration with only one resistor. If more accelerating resistors are added, they are set at around 2 seconds between steps. A note of caution. Due to the amount of current passing through during start, primary resistors become very hot and can cause severe burns. So when troubleshooting this type starter, please be careful.